Hey, welcome to Chapter 2, Pre-Calculus students. We're going to start off with just a little reviewing of solving quadratics and looking at a couple of different ways to do so. First one is just by solving by factoring like we've done in the past. So what we do is we first look at just trying to factor the quadratic like we normally do. Kind of breaking up that 5x squared, the only way we can do that is 5x in x. And then looking at combinations of that -6 to match up with these first parts here to get me that -13. So I think if we probably get -3 here, because that give me -15 here, and then a +2 here, because 2 times -3 give me the -6. And then the outsides, they give me -15. Insides give me +2, so they give me the -13. So, again, you could use Xbox if you wanted to, a little longer for that, to help you do that. But I think the guess and check method can be a little bit more efficient for many of you. And then again, now we're just looking at solving. We got this piece times this piece equals 0, so we either know 5x plus 2 equals 0, or x minus 3 equals 0. And solving that, you'd have 5x equals -2, divided by -5, so you get 5x equals -2/5. Or for the other one, when you solve that, you just get x equals 3. Just a little example for the first one. I'll leave the numbers 2 and 3 for you to make sure to do. Next group of problems are solving by using the quadratic formula. So if you don't remember what the quadratic formula is, it's x equals -b plus or minus the square root of b squared minus 4ac all over 2a. So again, maybe you had a teacher in the past that sang a little song to you. To Pop Goes the Weasel, like x equals -b plus or minus square root b squared minus 4ac all over 2a. And just remembering, that our quadratics have to be put in the form ax squared plus bx plus c equals 0. So go to have it in that form field, identify the a, the b, and the c. So that's what we have to do here with this first problem. Just kind of readjust that. So you got x squared plus 10x. Bring this 20 to the other side. Be minus 20 equals 0. So then you would know that your a value is 1, your b value is 10, and your c value is -20. And it's a matter of just putting it into the formula. X equals -b, so -10 plus or minus the square root of b squared, so 10 squared is 100, minus 4 times a, which is 1, times c, which is -20. And this would all be over 2 times a, which is just 2 times 1, which is 2. So cleaning this up a little bit, x equals -10 plus or minus. And we'd have 100 here, and this is minus 4 times 1 times -20. So this would be 100 plus, because you got minus 4 times the -20 be positive 80. And that'll all be over 2. So x equals -10 plus or minus. And then we have the square root of 180 all over 2. Excuse me. And just bring it up here. Just keep simplifying it a little bit. X equals -10 plus or minus. And then we've got to simplify that radical. And simplifying square root of 180 doesn't not come out evenly. But I do know, there's perfect squares I look to see that are in there. And what I can see is I know 36 times 5 would give me 180. So in other words, square root of 36 times the square root of 5 would give me the square root of 180. But the square root of 36 is 6. So I'd have 6 root 5 as a simplified. And this would all be over 2. And then I look to see, can 2 go into both those pieces? And it can. So I'd have negative 5 plus or minus 3 root 5 for the two answers. All right. Let you play with these other ones. You still got 5, 6, and 7 to do by using the quadratic formula. So make sure you get some practice doing that. The last one, group of problems, through 13 here are all solved by completing the square. And I'm going to take 2 of these problems. I'm going to do number 8 and I'm going to do number 11. Because number 8, leading coefficient is 1. Number 11, the leading coefficient is not 1. It's 8 in this case. So get 2 different scenarios for you to see and get some practice on. So first thing we do in completing the square is kind of almost the little different than what we do with using the quadratic formula. We don't want it in this ax squared plus bx plus c form. What we want to do is we want to take that c term and bring it to the other side. So I'm going to add 21 to both sides. So it would go away here, but I'd add it over here. Because now what I can do is I can complete the square. And I'm looking for rewriting this and getting this number right here, the c value, to be half of this b value squared. Well, half of this b value would be negative 6. If I squared it, it'd be 36. Because now I'd have a perfect square trinomial. But if I add 36 to the left side of this equal sign, I also have to add 36 to the right side to balance the equation. So again, always making sure that the equal sign, whatever I do to the left side, I got to do to the right side. This is a perfect square trinomial, which should factor into x minus 6 squared. And if I add these pieces here, that's just 57. Now, what I can do is I can square root both sides of the equation. I just get x minus 6, because the square root undoes the square. And remember now, anytime we square root both sides of an equation, we get plus or minus. And now here I just got to add 6 to both sides. So this would be 6 plus or minus the square root of 57. And there's our answers. Now a little bit more involved when we get to number 11, when we've got a leading coefficient here that's not 1. But we're still going to start off the same way. I was going to try to get rid of that c part and bring it to the other side. So this is going to take 8x squared minus 16x, and then I'm going to add 17 to both sides. So that would go away here. If I add 17 to this side, I just get 10. Now, we're going to do a little factoring here. I'm going to take out that 8 from both pieces. Because then what I'll have, if I take 8 out, I'll have x squared minus 2x in here. I don't have to worry about this side. And then inside that parentheses will be a problem just like what we have here back at the beginning, where our leading coefficient inside the parentheses is 1. So then I can kind of complete the square inside that set of parentheses. So I've got 8 x squared minus 2x. Now half of this negative 2 is negative 1 squared as a positive 1. Now this is where you got to be a little careful. You got to remember now, really I didn't just add 1 to this left side. This is 8 times 1. So I really added 8 to both sides. So I'm going to make sure I add that there too. That's the biggest mistake I see people make, is they forget they just add 1 to both sides rather than that 8 times 1. You got to make sure we get that distribution part. Now I can simplify this. This is a perfect square trinomial, so that's just x minus 1 squared. Again, it's just half of that b term. And this would be 18 on that side. So I can now divide both sides by 8. So I'd have x minus 1 squared equals 18 over 8. But that reduces to 9 over 4. And I can take the square root of both sides to undo that square. And I get x minus 1 equals, now again, when we take square root of both sides, I always get plus or minus. And then here's square root of 9/4, square root of 9, which is 3, square root of 4, which is 2. And can add 1 to both sides. So I'd have x equals 1 plus or minus 3 halves. And should be able to simplify that. So 1 plus 3 halves, or 2 halves plus 3 halves, is 5 halves. Another one, 1 minus 3 halves, or you can say 2 halves minus 3 halves, is a negative 1 half. Okay, so kind of an example of each. These 9 and 10 are like number 8. They don't have a coefficient other than 1, or leading coefficient other than 1. 12 and 13 do have leading coefficients that are not 1. So those would be similar to numbers 11. Okay, so have you complete this worksheet as prerequisite kind of information as we get going on chapter 2. So good luck, and we'll see you in the next video.